Okay, I want to talk briefly here about the firmware that's associated with the project. First of all, the firmware for the project is written in the cross-studio development environment from Raleigh, the ARM development environment. I chose Raleigh simply because it is the only development tool I know that you can purchase for $150 for personal development use. It has most of the features of a Kyle or an IAR type development system, but you can't purchase those for $150 for personal development. Beyond that, the Cross Studio tool comes with a CTL RTOS, and it is a pretty decent environment. Let's get started by reviewing some of the main files of the project. The project in itself is very large, much like any other major embedded effort. It's comprised of several thousand lines of code that I personally wrote to support all the existing hardware features that we have already covered. This is the main function. To start with, the main function, unique to the main function is it starts the RTOS environment. It initializes the RTOS, the event queues, the message queues, the mutex that will be used, launches all the tasks that are associated. These are all the tasks that are associated with the project, and provides sets the main task as the lowest priority task. Once everything else is set up, the main task will also set up the power saving mode for the calculator. In a nutshell, the calculator functions on a set of basic functions defined a calculator. Some things like the touch task. If you think about it, everything the calculator does is done from the function key. So one of the major tasks is that of the click task, which is any key that has to be pressed provides a function to the calculator. Whether the function be of a calculator function such as sine, cosine, tangent, square root, and some additional functions that are programmed into the calculator, or whether that function be a clock function or a power function or a meter function or a SD card function. Those things are also initiated via the touch task events. Another unique file to the calculator is the core function task. As you can imagine, the core file contains a lot of the core components of the calculator. Much of the core things that the calculator does is defined and coded in this file. Here are the defines for it. This is the structure type cal setting is the major structure associated with the calculator in its operating modes and how it's set up. As you can imagine, the calculator is built around the calculator part is built around math functions that operate in an RPM mode. The math function file, and this is a very large file, define numerous. Let's just look at the header files associated with that, and we can get a better feel for that. Define numerous, and here they are. These are all the math functions associated with the calculator. A ton of math function, conversion functions, trigonometric functions, statistical functions, polar, rectangular type functions, convert into hex, decimal, you name it, this calculator does it. Beyond that, as I said before, the calculator performs several meter tasks, that of a voltmeter, that of an ohm meter. These tasks are done here. The calculator also provides functions as a stopwatch, a clock calendar. It can also access the USB. It can also interface to a custom C++ Windows application that it talks to. Just a whole host of features that are covered by the calculator are coded in this environment. Real briefly, if you can look at any given function in the calculator. I pretty much code everything the same way. I like to establish a header file that is associated with the name file that will be used, pass my parameters, and this is unique to, I like to very clearly outline description of a function before I code it. I define the function, what are the parameters of the function, in this case it's void. The final parameters of the function, anything unique to the function, and then describe step by step the actions that will take place as part of that function. And that is through across the calculator. Here goes another function, returns a type boolean. All that's described here, and you'll see that throughout the calculator. So in a nutshell, this is the, just briefly wanted to show this to you. This is the embedded environment. Again, several thousand lines of code that are compiled for my project, all written exclusively by me. The low-level stuff, the higher-level stuff, the interfaces, the USB interface to the calculator, support functions, and the WinApp. All that is done here. And hope you enjoyed the tour of the firmware. Next we'll be discussing the software associated with the WinApp.